Alright guys, let's get into some examples on solving equations with rational numbers, and we'll also take a look at solving one-step equations just with integers. So for the first example, I want to look at h plus 31 is equal to 60. Remember, with one-step equations, you want to make sure that you are first identifying your variable, which in this case it's h. Then you want to isolate it, and in order to isolate it, you want to do the inverse operation. So first I want to see what's going on in the problem. So h is actually adding 31. The inverse is going to be subtracting 31. So I'm going to subtract 31 on both sides. Now if you need a calculator to help you out, you can do so. I'm going to cancel out a positive 31 and a negative 31. I'll have h on the left hand side. If you want to show your work here, you can. 60 minus 31. You're going to borrow from the 6, make this a 10. You'll be left with 9, 2, 29 is equal to h. That's your final answer. Alright, let's look at the next example. This one's going to be dealing with decimals, so I'll have f minus 4.19 is equal to 3.51. Again, my variable is f. I want to get this isolated by itself. It's subtracting 4.19, so I'm going to do the inverse, which is adding 4.19 to both sides. Again, add 4.19 to both sides. A negative and a positive will cancel. I'm left with f on the left hand side. On the right hand side, again, you can show work here. When you're adding decimals, make sure you line up your decimals. You'll be left with 10 here. Drop down to 0, carry the 1, 7. Bring down your decimal. 3 and 4 is 7. So you'll be left with 7.7 for a final answer. All right. Let's look at another example of one-step equations with just integers, not rational numbers. We'll do that for the next one. So m plus 72 is equal to negative 19. Here again, identify m as the variable. In order to isolate it, do the inverse. So I'm going to subtract 72 from both sides. A positive 72 and a negative 72 will cancel. I'm left with m. Now here you have two values, right, that are negative. So you have negative 19 and a negative 72. If they have the same sign, okay, you're going to be taking the sum here. So in this case, right, if we add these, you'll get 91, and then keep the sign of both these numbers. If you owe me $19 and then owe me an additional 72, in total you'll owe me $91. Alright, let's move on to number 4. Okay, number 4 deals with, decimals. So we'll do this again. And we'll actually use division problem instead. So negative 2q is equal to 12.84. Q is my variable. It's multiplying negative 2, so the inverse is going to be dividing by negative 2. Instead of writing the division sign, I'm going to write this fraction sign. Divide a negative 2 by both sides. Left hand side, a negative 2 and a negative 2 will give you 1, or just simply 1q, or just q. And the right hand side, I have to actually do some work here. So in this case, I'm going to have 12.84 and a negative 2 on the outside. How many times does 2 go into 12? 6. No remainder. Drop down the 8. How many times does 2 go into 8? It's going to be 4. Make sure you line up your decimal, right? And this is going to be 8. No remainder again. Drop down to 4. 2 goes into 4 2 times. No remainder. And remember, it's 12.84 divided by negative 2, so for our final answer you're going to have negative 6.42. In the event that you're multiplying a decimal by decimal, you want to move the decimal place over in the number that's on the outside of the division sign in order to make that a whole number. Now if you move that one place over to the right, you're going to move the number that's inside the division sign one space to the right. Alright, let's go over, let's see, two more examples. Number 5 is r over negative 9 is equal to 12. So r is my variable. I want to get it isolated. It's dividing by negative 9. So the inverse here is going to be multiplying both sides by negative 9. Okay? Now you can put a 1 over it. If you're multiplying fractions, you will get negative 9r over negative 9. Or you'll simply just get 1 or 1r or just r. On the right hand side you have 12 times negative 9, okay, which will leave you with a negative 108. If you want to check your answer for these, you can. It's totally up to you. Let's see if we can squeeze in one more example. I'm going to squeeze it in right here. Number 6 is going to be, let's see, 5 over 6, we'll say x, which is equal to 2/3. Okay, now x is my variable. What's happening to x here? It's being multiplied by 5/6. So in order to cancel out that 5/6, you want to do the opposite. So you could essentially divide this x by 5 over 6. However, if you divide 5 over 6 divided by 5 over 6, you're going to have to do keep, change, flip. And it's going to say 5 over 6 times 6 over 5. So a good rule of thumb is just simply multiply both sides by the reciprocal. Okay. Now if you have 6 times 5 over here, you'll get 30x, and the bottom is going to give you 5 times 6, which is 30. 30 over 30 will cancel out. It will just give you 1. Remember, you still have the x here, so bring that down. And then on the right hand side, you're left with 2 over 3 times 6 over 5. Okay, 2 times 6 is 12, and 3 times 5 is 15. You're left with a fraction that can be simplified or reduced a little bit further. And you could divide top and bottom by 3, giving you 4/5 for a final answer. Alright, if you need to check any of these answers, you can plug them into the original problem. And if both sides are equal, then you know that you got the right answer.